In this video, I'm going to look at an easy way to expand a binomial. So by expand, we're talking about some binomial, whether it's x plus y or this could be anything, but x is the first term, y is the second term, and then you take this to say a power. And we're talking, in this case, we're looking at a positive integer power. Okay. So just to give you some perspective or review, let's look at some that I have here. So I have x plus y to the 0 power is equal to 1. So first of all, I want you to think of x as the first term of the binomial and y as the second term. And keep in mind that those could be anything. It could be 3x squared plus 5y to the third. Okay, they're just terms. It doesn't have to be just an x or a y. But just for the sake of this argument here, we're using x for the first term, y for the second term. Okay, so x plus y to the 0 power, straightforward, is equal to 1. X plus y to the first power is just one factor of x plus y, so obviously that gives me x plus y. And x plus y to the second, you can multiply that out either way you want. Either write it out as x plus y times x plus y. Okay. Now I haven't gone to the shortcut or the easy way yet. I'm just giving you some little background here. Okay, so then multiply this any way you want. X times x, x squared, y times y, y squared. This product this way is xy, this product this way is xy. So 2xy's added together gives me a 2xy. Okay. Or you can just realize if you have a binomial squared, it's the first term squared plus, if this is a plus, double the product of x and y plus the second term squared. Okay. Now, obviously, if you have x plus y to the third, that means 3 factors of x plus y. So we go this way and get this, and then in turn you multiply this by x plus y. This is the long way to do it. Right. And you go x times x squared is x to the third. X times this is 2x squared y. And then x times this is xy squared, and then you multiply by the y and so forth, and you combine your terms and you come up with this right here. Okay, so I just want you to see the pattern here. So first of all, we want to notice this. Okay, we have the binomial on the left side, to a power. And on the right side, we have what we call the expansion. What do you get if you take that binomial to that power? Okay. So first notice this, that the number of terms on the right side is always one more than the power. Okay. This is 1, obviously one term, and 0 and 1 is 1. Okay. You got one term. Okay. X plus y to the first, we got 2 terms there, and that's one more than 1. That's 2, okay? X plus y to the second has 3 terms, and that's 2 plus 1, okay? And the next one, x plus y to the third, has 4 terms, that's 3 plus 1, okay? So the number of terms on the right side is one more than the power on the binomial, okay? Also notice, let's look at this one as our base example, okay? Notice that the first term of the expansion, the expansion is over here, is always the first term here taken to that power. So x to the third, taken to the third power is x to the third. And then the last term over here is the second term taken to that power. Y to the third is y to the third. Okay. So you can always get the first and the last term of the expansion by inspection, just by looking. And then notice that the power, once you have the first term, the power on the x decreases. So it's x to the third, x to the second, x to the first, and then x to the 0. Okay? The power on the y of the second term increases as we go from term to term. So starting with the first one, right here we don't have a y, so that would be y to the 0. So it's y to the 0, y to the first, y to the second, finally we get to the last term, y to the third. Okay? Also notice that the degree of every term is the same as the power. Okay? On the left side. Okay? This is degree 3. This term is degree 3. This one is degree 3, 2, and 1. That's where you get the degree if it has 2 variables. Here it's 1 and 2. That's 3. And this one has 3. There you have it. Okay. So if I give you, say, x plus y taken to the 50th power, 50th, and I tell you how many terms will this expansion have, then you should know it's going to have 51 terms. If you actually multiply this out, but you don't want to do it, but you're going to have 51 terms. And just by inspection, I know that the first term is this first one taken to that power. I know that the last term, or the 51st term, is y taken to that power. Y to the 50. Okay? And then we can fill in the rest. Okay? But that's one thing you know, just by inspection, you should know. You should know those things. Okay. Now, if I want to look then at x plus y to the 4th power, then again, based on what we just observed, the first term has to be x to the 4th. And the last term, or the 5th term, would be y to the 4th. And then the other thing, if you look at the examples here, every term of the expansion is going to have the x and the y in it, except for the power 0. See this one here, x squared y, okay, x y squared. Now here you say, well, this doesn't have an x, well, the power is 0, x to the 0. Or this one doesn't have a y, well, the power is 0. Okay, so every term will have an x and a y, whatever the terms are, except for the power 0. Okay, so based on what we said then, we said the power on the first term decreases as we go through the expansion. So the next term should be x to the 3rd. Okay, and the power on the y, or the second term, increases. So in the first term it's to the 0, so this should be 1. And then these always have to add up to whatever the power is, 4, 4, okay? And it's plus. The next one should be x squared, y squared, okay? One increases, the other one decreases. Plus, the next one should be x, y to the 3rd. And the next one should not have an x, because from x to the 1st, I go to x to the 0. That's just going to be 1. And then, okay, so there you have it. So the only thing that's missing is the coefficients. Okay? So I'm going to do this. So follow me here, and then I'll explain it to you. I'm going to say 4 times 1 is multiplying the exponent times its coefficient. So 4 times 1 is 4. Divide by the position in that term. That's the first term. 4 divided by 1 is 4. Okay. Now 3 times 4 is 12. And that's the second term, so I divide that by 2. Okay. That's 6. Continue. See, it's always the power on the first term that I'm working with. So 2 times 6 is 12. Divide by 3, because that's the third term. is 4. And then 1, and this one has a 1. Now 1 times 4 is 4. That's the fourth term. 4 divided by 4 is 1, so that's just going to be a 1, or just y to the fourth. Okay, so there we've derived the answer to that problem, x plus y to the fourth. Now we could have done it by just saying x plus y times x plus y, and then multiply all of that by x plus y again, and then multiply again by x plus y, combine the terms, and then we have it. Okay, so again, observing what we just said, if I have x plus y to the fourth, the first term of the expansion should always be the first term here taken to that power, x to the fourth. The last term should always be over here, should always be the second term of the binomial taken to that power, that's y to the fourth. And then the variable part, starting with the first term, the power on the x decreases, the power on the y increases. So remember here it's y to the 0. So we'll go x to the third, x to the second, x to the first, x to the 0. And then for the y, y to the 0, y to the first, y to the second, y to the third, and then finally y to the fourth. Okay. And again, just like this one right here, same way, x to the third, x to the second, x to the first, x to the 0, y to the 0, y to the first, y to the second, y to the third. And again, I found that this method is 3 times 1 is 1, divided by 1 is 3. 2 times 3 is 6, divided by 2 is 3. 1 times 3 is 3, divided by, 3, because that's the third term, I get 1. Okay, now all of these little steps that I'm going through basically follow from the binomial theorem, okay, which I won't go into real detail in this video. I've done other videos on the binomial theorem. This is just the shortcut that comes from it. Okay, so let me just clear this. And again, in case you can see, I can't read my writing. Okay, this is the answer that I just get. X plus y to the fourth is x to the fourth plus 4x to the third y plus 6x squared y squared plus 4x y to the third plus y to the fourth. Now again, I said keep in mind that x is just the first term, y is the second term. But it doesn't have to be x and y. It could be x squared or 3x squared. And the y instead of y could be 5y or 5y to the negative 1 or something like that. Okay, here the main power here, we're treating it to be a positive integer. So let's look at one like this now. Two x plus 3y to the fourth power. Okay, so now keep in mind that now the first term is 2x. It's a binomial. The first term is 2x, and the second term is 3y. Okay, so I'm going to set it up just like I did this one right here. And just to have enough space. I know then, but from what we said, the first term is going to be 2x taken to the fourth power. Okay, so I'm going to put this in parentheses. Okay, and these examples that were just x, but now instead of just x, it's 2x. Okay, so 2x is the first term, 3y is the second term. Okay, so now I'm going to do this. Same thing I did, except now, because I have a little bit different situation, I put this in parentheses. So the terms of this expansion then are, or the terms of the binomial are 2x and 3y. So this just goes 2x to the fourth, and then just decrease the power on that in the next one. So this is going to go to 3, and then 3y. Okay, so here it's 3y to the 0. So this goes to the first place. Okay, and it's a plus. Then again, decrease the power on the first term and increase it in the second. Here the first term is 2x, second term is 3y. So this one now goes to 2. And the power on the 3y goes from 1 to 2. It increases. Okay, and it's plus. Again, keep it in parentheses, just to play it safe. 2x. The power on that one goes to 1. Okay, so I can, here it's understood. So I can put a 1 or just leave it as 2x, but I'll go ahead and put the 1 there. And then 3y to the third. Okay, so keep in mind again, these powers have to add up 3 and 1, 2 and 2, 1 and 3. They have to add up to 4. Okay, then the last term will be 3y to the fourth. And the 2x goes to a power of 0, so that's just a 1, so I leave it. Okay, so now just like on this one right here, I'm going to do the same thing, except instead of just an x and a y, I have a 2x and a 3y, but it's still going to work the same. Here I sense it to be a 1 here, so it's 4 times 1 is 4 divided by 1. That's 4. So 4 goes here. 3 times 4 is 12 divided by 2, because it's the second term. Goes to 6. This will be 6 here. And then 2 times 6 here. Remember, it's always the power of the first term, which is 2x. So it's 2 times 6 is 12 divided by the position of that term. That's the third term. So 2 times 6 is 12 divided by 3. That's going to be 4. Okay. And then it's 1 times 4 here. 1 times 4 is 4. Divided by 4 is 1. So you get that. Okay. Well, then you have to do the calculations here. So then here is going to be 2 to the fourth will be 16. And x to the fourth is x to the fourth. Okay, so that gives us the first term. Okay, so here we have to do a little bit more work because instead of just x and y, we had 2x and 3y as the terms. Okay, so then we have, this is 4, and then 3, 2x to the third. That'll give me 8x cubed. Okay, so I have 4, and then 8x cubed, and then times 3y. Do your calculations on that. And that should come out to 96 x to the third. Y. Okay, and then it's plus. So on this one here, this would be 2x squared. This would generate 4x squared. And then 3y squared would be 9y squared. Okay, so that's just a matter of multiplying those out. And we get 216. X squared. Y squared. Okay, and then it's plus. Now we're the next one. So this is 4, 2x to the 1 is just 2x, and then 3y to the third will give us a 27y to the third. 27y to the third times 2x times 4. We do the multiplication there, and we get 216. X, y to the third. And then finally for the last term, 3y to the fourth, okay, that'd be 3 to the fourth is 81. And then y taken to the fourth power. So give me this. So there we have it. 16x to the fourth plus 96x to the third y plus 216 x squared y squared plus 216 xy to the third, and then plus 81 y to the fourth. Okay. clear this, and then give you the answer over here in case you could read my writing. Okay, so just a simple little shortcut to expand your binomial, and like I said, the techniques that I went through here are derived really from the binomial theorem. And there's other techniques that you can use, such as Pascal's triangle, to come up with the coefficients. But anyway, that's just a little shortcut to expand the binomial. This will conclude the video, so thanks for watching. We'll see you next time.